So today we are going to start looking at volume, and by the end of class we are going to be able to answer the question of how do we find the volume of cylinders and cones. So let's talk about volume. Volume is nothing more than the amount of three-dimensional space occupied by an object. Okay. Sometimes we may see this referred to as capacity. Okay, capacity. So what we're really looking at is how much space is inside this cylinder. Okay, so let's talk about a cylinder here. So a cylinder, we know, has two circular bases and connected by the height. So some of you may have had your Monster drink or maybe a soda can this morning. I'm trying to think of that other Prime. That's one of my son's favorites. Okay, they're all in that can is like a cylinder. Okay, so let's look at volume of a cylinder by looking at the formula here. So volume is equal to big B times H, and I do refer to this as big B. And that big B is nothing more than the area of the base. So when we look at the base of the cylinder, well, what are the bases of the cylinder? What shape are they? Well, they're circles. So big B, we can replace, what we're doing is we are finding the area of a circle. And we know from our most recent notes that area of a circle is pi r squared. So what we're going to do here is we are replacing this big B with whatever we get with pi r squared, our calculation for pi r squared, and then we're going to multiply it towards our height. Okay. One thing to always remember is that our height connects the bases. Okay, I'll put this off to the side here. Height connects the bases. Okay. So let's start working with cylinders. One thing we know is always true is that the base of a cylinder is always a circle. So let's take a look at this first one here. Okay. So here I have a cylinder. Okay. I'm going to identify my bases. So here's one base. Here's my other base. And then my height connects the bases. So over here, this is my height. Okay, and if I were to sketch my base, it's a simple circle. Okay. So our first thing is we need to find the formula for big B. So big B is area of the base. So what I need to find here is what is the area of a circle. We know the formula for area of a circle is pi r squared. What is one thing that we need to find the area of a circle? Well, we need the radius. And it has given us the radius right here as a radius of 4. So to calculate that, I'm going to plug that into my formula, and you know I could do the pi 4 squared, or it's the same as pi 4 times 4. Okay. So I'm going to plug this into my Desmos calculator, and let's round this to the nearest hundredth. So that's 2 decimal places after. And when I plug this in, using my pi key on my calculator, and typing in my 4 times 4, I'm left with 50.27. Okay. So this only gives me the value of big B. We're not done yet. We have not calculated our volume. Okay. We've only found one part of it. Now I'm going to go back up to my formula And the formula for volume of a cylinder is V equals big B times H. I need two things. I need the area of the base, which is here, and I need the height. Well, I just found the area of this base. So I'm going to plug this into my formula at 50.27. And now multiply it times the height, which I was given as 7. So I'm going to go back to my trusty Desmos calculator, and I will round this again to the nearest hundredth, and when I plug that in, I'm at 351.89, and then I always want to have a label. I just noticed that we didn't label the diagram, so let's just call this in inches, okay? And this is going to be inches and cubed, because remember, it's the amount of three-dimensional space, so that's why it's going to be in cubed. Okay. So let's try another one. So we look at our next example. Okay. We recognize that we have a cylinder. So the first thing to do is identify which one is the base. Well, we know the base of the cylinder is a circle. Okay, so this is a base, this is a base. And then I'm going to identify the height. Well, height connects both of these bases. So let's see, I'm going to sketch my bases here. And then I have 6 meters. Okay. So now, first, before we can plug this into our volume formula, we need to calculate the area of our base. Since our base is a circle, area is pi r squared. Now notice, what did they give us? Did they give us radius? Did you catch on? They did not. They gave us diameter. So diameter is, to find that, we have to 1/2 that diameter to give us the radius. So half of 6, that radius is going to be 3. And now we can plug this into our formula, which is pi r squared. Or I can do pi 3 squared, or pi 3 times 3. Okay. So let's go over to our trusty Desmos calculator, plug that in. We will round this again to the nearest hundredth. And I'm getting 28.27. Hopefully you got the same. So this is our big B, and we're not done yet, okay? Because now I'm going to substitute it into my volume formula. So I'm going to go into my volume formula, my big B. I'm going to type in my 28.27, and I'm going to multiply this to my height. And we already said here height connects the bases, so my height is at 5. And now let's plug this into our Desmos calculator. So I'm going to type in 28.27 times 5, and I'm getting a volume equals 141.35. And then I'm going to add a label to it. Well, this one here says it's in meters, and because it's three-dimensional, cubed. So now let's flip our notes over, and let's take a look at volume of a cone. So as we know, a cone has a circular base, and the height connects to the tip here. And so we're lumping both our cones and our cylinders together because of the shape of the base. Here is the formula to find the volume of a cone. Okay, that volume is 1/3 times, here's that big B. We know that big B is the area of the base times the height. And when we look at the shape of the base, well, the area of the base, this is just a circle. So just like our cylinders, we know the area of a circle is pi r squared. So let's take a look at our first example. We're asked to find the volume of this cone. So if we sketch the base here, hopefully we're identifying that base is a circle with a radius of 6. So our formula for finding that big B, remember that big B is just that area of the base. That's going to be that pi r squared, because that's how we find area of a circle. And we can write that out as a pi 6 squared, or pi, we know it's 6 times 6. And now let's plug this into Desmos. I'm going to plug this into Desmos, and I have 113.1. Okay. So here I just found big B. I'm not done yet. Whoops, I'm not done. Okay, I'm now going to take that big B and I'm going to plug it into my volume formula. So my big B is at 113.1, and I'm going to multiply this by the height, which is 8. And now I am going to be plugging all of this into Desmos. So I'm going to do 1/3 times 113.1 times 8. And when I plug this in, I receive that the volume is, I get 301.6. And I want to add a label to it. Oh, well, we'll just call this one inches. Sorry about that. Okay, inches. And because volume, we're dealing with 3-dimensional, it will be cubed. Taking a look at the next one, same thing. Here we're going to find the volume. So I know with my volume formula that volume is the 1/3, right? My big B times H. And the great thing, don't feel like you have to memorize this formula. It is on your star chart. So if I sketch my base below, it's a circle. Right, and it has 44. Now I'm recalling that it gave me diameter. Okay, so I need radius. So if I take 44 divided by 2, I'll get the radius. So my radius is 22 centimeters. Now I'm going to calculate my big B, or my area of a circle. So my formula is pi r squared. I'm left with pi 22. Make sure you use your r, not your diameter, your radius, not your diameter. I can plug pi 22 squared into my Desmos calculator, or pi 22 times 22. And for my big B, my area of the base, I have 1,520. And I'm going to round this to the nearest hundredth, 53. But I'm not done yet. Okay. That is my big B. I'm now going to plug that into my volume formula. So here I have 1520.53 times my height, and the height is what connects my base to the point. So this is my height up here. So I'm going to plug in, I'm going to multiply 1520.53 times 51. That's my height. And I'm going to take that, multiply it by 1/3. So let me finish plugging all of this into Desmos. Go ahead and plug all of this that I'm highlighting here into Desmos. And when I do that, I have the volume equals 25849.01. And then I'm going to give it a label, centimeters cubed.